All right, so as we're getting started here with our super stairs and our steps, right? What you should have put down is something that looks like this. Did you get that? Everybody good, right? So it's double for each one of those, right? Now, what do you notice pattern-wise here in terms of like, we kind of have a sort of a sequence here, right? Like, is there anything particular about this sequence that you notice? Does it fit in any of our categories? It's what? It's, how do you know it's arithmetic? So there's a what? There's a common difference of positive 2. Okay. All right. So we can kind of do a little positive 2 here, positive 2 here, positive 2. Okay. All right. So we've got a common difference of 2. All right. So we've got this arithmetic sequence. All right. So here's my first question. So you guys said he created more work for himself, right? So if he does a super stair set of 5 super stairs, then what I want to know is, how many steps total did he take doing 5 super stairs? How could we figure that out? How could we figure out how many total steps he took? Adding what up? Okay, all right. So we could like start with for like 2, and then we would add to that 4, and then we would add to that 6, and then we would add to that 8, and then we would add to that 10, and then we would have to like add all those up. Okay, all right. Well, you do that. What do you get? What do you tell me what you get up? 30? 6, 5, 18. Yeah, 30, right? Okay, 30. Okay, so he takes 30 steps, right? If he does a 5 super stair set, he takes 30 steps. Everybody good with that? Okay, so I'm going to give you a piece of important vocabulary right here. I want you to underline this and then shoot a little arrow off here. Okay, when we write out our sequences as a long addition problem right here, that's called a sum of terms. You're going to see that language on your homework and on your tests. So if I say, write this out as a sum of terms, what I'm looking for is a math problem that looks like that. Okay? That's a sum of terms. Okay. All right. Well, what if he did an 8 super stair set? 8 super stair set. Why don't you write me a sum of terms for an 8 super stair set and see if you can come up with the total number of steps he takes for 8 super stairs. Go ahead. With that on your paper right there. Okay? Now, again, it's important that you write all of these out like that, because what did I ask for? A sum of terms, right? So you've got to write that out. That's one of the things that I'm looking for when I ask for a sum of terms. All right, well, let's go back and title our lesson here today. You can see what we're kind of working on. So this is going to be lesson 1.3, and this is going to be the sum of arithmetic sequences. The sum of arithmetic sequences. Because right now, I mean, we have sort of a clunky way of doing this, but let's just make a note of our goal for today's lesson. And our goal is to find the sum of a certain number of terms in an arithmetic sequence. But here's the key part. We want to do this using algebra. Because, I mean, yeah, we can write out these sum of terms and we need to know that language, but, I mean, this really isn't the most efficient way for us to do it. I mean, neither is it really the most efficient way for us to go like, okay, well, 6 is 12 and 7 is 14. And if I carried this out a little bit further, and I could go 8 is 16, and to keep going like that. I mean, either way, it's not the most efficient method, right? Or at least we hope it's not the most efficient method. We hope there's a more efficient method, right? Okay? All right, so here's what we're going to do. Let's consider for a moment a problem that we know the answer to already. So we're going to consider an 8 superstair set. All right, so let's consider 8 superstairs, and we're going to kind of study this a little bit. All right, so here's what I want to do. Let's start with the first 8 sets of steps here. So, and we're going to write a little space in between them. So 2, and then 4, and then 6, and then 8, and 10, and 12, and 14, and 16. We good so far? Okay. All right, now we're going to kind of find sort of a middle point in this sequence of numbers. We've got 8 terms, so we could take this and we can kind of split it down the middle right here in between 4 terms. And we're going to consider a couple of terms together. We're going to partner up some terms together the same distance from that middle. Like, for example, let's take these 2 terms right here, and let's partner those 2 terms up. Now, if we take those terms and we add them together, what are we going to get? 18. That equals 18. Okay. Let's take 2 steps away. So what if we took this term and we considered them together? What are we going to get? Oh. That's interesting. What about this one and this one? What do we get? Another 18, huh? Looks like there's some kind of a pattern happening here, doesn't it? So we go here and here. We consider these terms together and we add them up. What do we get? 18. Okay, 18 again. All right, so there's obviously something going on here, right? All right, let's make some notes here. So how many total terms were there that we were considering here? Okay, 8 total terms. All right, how many pairs of terms were we able to make? Okay, we were able to make 4 pairs of terms. And each pair that was equidistant from that center point added up to 18. So we could kind of like thin things down a little bit here, right? We've got 4 pairs that add up to 18. 4 18s, right? What math would we do if we wanted to come up with 4 18s? 4 times 18, right? So another way that we can write the, watch this, the sum of these 8 terms, you see what I just did there? Another way we could write that is 4 sets of 18, which is 72 stairs. Does that make sense? So if we know what one pair adds up to, we know how many pairs there are, and the pairings all equal the same amount, then we should just be able to multiply how many pairs we have times the sum of these 2 terms that are equidistant from that center part of the sequence. Okay? So, as we have done, then let's consider superstairs. Because that would be really efficient, right? Like, I mean, if we could just plug in any number we wanted to say, hey, how many steps is he going to take if he does a 12 superstair set or an 18 superstair set or a 20 superstair set? How many steps is he going to take? That'd be a really handy thing if we could do that. That would be a super efficient way instead of writing out like, you know, plus, right? Okay. Well, why don't you see what you can come up with for a math problem that would help you calculate superstairs. Generically. We're going to write this generically. You know, like with variable-ish kind of things that we've been using and, you know, I don't know. See what you come up with. Give it a try. Write something down you're working in pencil. You can always erase it, right? If you're not working in pencil, you should be working in pencil. You know, then that way you can erase it. I mean, just going off the pattern that we have up there, right? Like, just how many of you got this? Did you get that? Okay, right? Because that's like the sum of superstar sets, right? Okay, all right. Okay, the 4. Where'd the 4 come from? half of the number of terms. Well, we have something that represents the number of terms up here, right? What represents the number of terms? N, right? So we just want half of that, right? That would be the first number, yeah? Okay, so then we got to multiply it by something. This is where it gets tricky, huh? Because, like, we don't, I mean, how do you say, like, which set, multiply it by? Yeah, what if we did that? We could do first term and last term, right? Because we know what the first term is, right? Because it starts the sequence, right? And it doesn't matter what the pairing was, because the first term and the last term are always going to be equidistant no matter what that middle point is, right? So how would we write first term? A1. Okay, A sub 1. How would we write the last term? A sub n. Sure, that would make sense, right? Because, like, if it's 9 terms or 8 terms, right? In this one it was 8 terms, then that would be the sum of 8. That would be 8 divided by 2. So then the 8th term would be A sub n. Okay. All right. Very good. Nice job, you guys. This is called the sum formula.
Why would you have to have A sub 1 and why would you divide it by 2 on average?
Because we're not finding the average here. We're just adding these terms together. What we're dividing by 2 is taking the entire set of terms and pairing them up into groups. That's what the dividing by 2 does for us. All right. Okay. Let me just a second. Let me show you something. If I gave you this and I said, tell me the first 4 terms of the sequence, tell your neighbor the first 4 terms of the sequence right now. Go ahead, you do it. Tell your neighbor the first 4 terms of the sequence. Right? What are the first 4 terms of the sequence? Who's got them? Who can tell me the first 4 terms? Raise your hand. Who's got it? Sophia, you got it? What is it? 10, 5, 2.5. Perfect, right? Awesome. That was really good. Did everybody else get that? 10, 5, 2.5, 1.25. How did you know to do that? Because you know how to read that, right? You know that this is what kind of a formula? This is a recursive formula. And what does a recursive formula do for us? Gives us the next term in the sequence, right? Okay, and so with this particular recursive formula, where do we start? We start at 10. We started at A sub 1, the 10, right? And what do we do every time? Yeah, we divide by 2 or multiply by half, right? So see, by understanding how to read that algebra, you're able to provide the answer, right? And that happens a lot of times. I mean, think about y equals mx plus b. Same kind of thing, right? You understand how to read that, right? Well, today you're going to learn how to read that. This is called summation notation. And this is what we're going to use. This is a question. Just like I asked you a question a second ago with this, and you were able to answer that question, I'm going to ask you a question like this. So let's talk about how do we answer a question like this. Here we go. All right, write this down. This is called summation notation. Okay? So summation notation works like this. I want you to skip a line, and then we're going to draw what's called a sigma. This is a capital S in Greek. Okay? So it's kind of like a bent E. All right? Now you're going to see some kind of different notations here. I'm going to use an N because we're used to using N. But you could have any letter down here. It could be any variable. It could be B or I or Q or P, doesn't matter. So we're going to use this N down here, and then we're going to use an M up here. And again, this is just, could be any variable. Okay, so let's notate what these are. So this one right here is our beginning, we'll just say begin, we'll abbreviate it, beginning term number. This is the not the sequence value. This is the term number. This is the first term in the sequence, right? Term number 1. That's what we're talking about. And this one right here is going to be our end term number. This one right here is going to be our end term number. Okay? Now, in this picture right here, where do you begin with what term number? Okay, and where do you end with what term number? Okay, all right. See, look, you're already starting to understand it. See how it works? Okay, now you got this funky thing going on right here, though, right, that we got to concern ourselves with. So let's notate what that is. And that is our explicit rule or formula, right? Explicit formula. Well, we know what that is. We just took a quiz on that, right? In fact, let's do this. Let's kind of come over here on our notes and let's do a little squiggle squazza, a little like that. And what I would like you to do is I would like you to write the explicit formula for this sequence that we're working with right here. Write the explicit formula showing your work for this sequence that we're working with right here. Okay? Go ahead. Give it a shot. This is what you should have come up with right here. Right? And I mean, think about it. Doesn't that make sense, right? For every, whatever superstair set, we say, if it's the 7th superstair set, right? That would be A sub 7. Then we plug in a 7, multiply by 2, and he gets 14. He goes up 7, he comes down 7. 14, right? Because it's always double every time we look at it. Does that make sense? Everybody good? Okay. So then let's do this. Give yourself a little squiggle right here. What happened to my little squiggle? Oh, there's that one. All right, give yourself a little squiggle here. All right, you ready? Right here, I want you to write the summation notation that answers this question. How many total steps does he take if he does 8 superstairs? Write that question in math language, in summation notation. Let me say it again. The question is, how many total steps does he take if he does 8 superstairs? Write that in summation notation. This is like me saying, hey, write the recursive formula for, write the explicit formula for, write the summation notation for, how many total steps does he take if he does 8 superstairs? With that. Think about it. Doesn't that make sense? Doesn't that answer the question right there? Right? If we know that the formula is double the term number, what is the sum from 1 to 8 doubling each one of those numbers? Okay, let's be clear about something right here. Box this in right here, and let's be clear about something. This right here is a question. This is a question. Just like when I put this up on the screen, right? That's a question, right? It's asking you to find the terms in the recursive sequence, right? Well, just like that, this is a question here. Now, how do we begin to work out that question? Well, let's start to turn this into some math that we can work with, okay? And that's where this comes into play. See, because it's this formula right here that allows us to figure out the sum of some sequences. So let's take this question and translate it into this information right here. So right here, I want you to do this for the problem that we just asked the question of. Give it a shot. See what you can do. It's worth taking a shot. Let's see. Did you get that? Do you see why it's that? Okay, let's talk about why it's that. This right here is the math problem that finds the sum of any sequence. We take the number of terms, we pair them up, so we divide them by 2, and then we multiply that by the sum of the first term and the last term. So here is the total number of terms in our sequence, starting at 1, ending at 8. That's 8 terms. We're going to set that into pairs, and then we're going to use the first term and the last term. That's the explicit formula. This is the rule that governs the math that helps us find the sum of each of those problems. So in this case, the math is if he takes 3 steps, we're going to double that because that's what we want for the number of steps he takes. So if he goes up 3 stairs, we're going to double it. If he goes up 12 stairs, we're going to double it because he goes up 12 and he comes down 12, right? And each one's going to be different, right? Every math problem is going to have its own thing. Does it make sense? Do you see why? Okay. No? Yes? It does now? Okay. All right. And I mean, if you wrote the S sub 8, no, that's okay too. I mean, you don't need it, but I'm just saying this is the actual math that we're doing, right? Because look, watch what happens when we simplify it. In fact, let's do this. Let's box this in real quick. And then let's just say this is our how, right? Which is our sum formula. That's what we're using. So we take the question and we turn it into a action math problem with our sum formula. And then we just simplify, right? So we get 4 like that. So then we get 8 divided by 2 is 4, and then 18, and then 72 is our answer of the question that was asked right here. And this is just simplify. Summation notation. So if I give it to you in words, you need to be able to write me the question in summation notation, which you'll need an explicit formula to do, and you'll need to know how many terms there are in your sequence, okay? And so this allows us to do what's called a partial sum of a sequence. Yeah? There will be questions where you'll just be given this right here with an explicit formula, right? And you'll have to calculate what is the sum of that particular problem. But I mean, let's go back. Let's just go back to this one for just a second. Here, let me go here. Maybe. So you might just get a question like this. Let's do this one. Okay? Just for the fun of it, let's just do this one. You can turn your paper over on the backside if you want. Yeah, go ahead. Give this one a shot. See what you can come up with. In going from the first step out, it should look something like that. Yes, ma'am. That's a great question. Does anybody know how I got 5 and 45? Yeah, I can. But I'm curious, does anybody know? Nick, how did I get 5 and 45?
Because G times 2
Listen.
times 1, which is 2, and then you added 3, so it's 5.
So this right here governs what turns the term number, right? That's n, right? The term number is n. That governs, that's the math that governs what turns the term number into the sequence value. That's what the explicit formula does for us, right? Remember, right? The whole point of the explicit formula is this right here is supposed to tell us the sequence value of any term number. So the first term number would be 2 times 1 is 2, plus 3 is 5. Right. And what's the last term number going to be? What term number is the last one in the sequence? 21. Plug it in. What's 21 times 2? 42 plus 3. That's where the 45 comes from. Which is why it's really helpful to use the first term and the last term. Because in our summation notation, we're going to have the first term down here, and we're going to have the last term down here. And then once we know how many terms there are, we can cut those into pairs. And so then we're able to calculate this out. Right? Now, this is usually how I do these types of problems, okay? If this is an even number, like it was in our 8 divided by 2 is 4, I usually just divide that by 2. If it's not an even number, then usually what I'll do is I'll go like 21 times 50 divided by 2 like that. Same thing. And then if I can cancel here and here, then I can say that the sum of these numbers is 21 times 25. What is that? You do that. I don't have it in front of me. 525. And what we could do is we could write this out as a sum of terms, because it's an arithmetic sequence. And so we could go, well, let's see. The first term was 5. What's the second term in this sequence? No. Second term in the sequence. What's the value of term number 2? 7, right? 2 times 2 is 4, plus 3. What's the value of the third term in the sequence? 9. 3 times 2 is 6, plus 3 is 9. What's the value of the fourth term in the sequence? What's the common difference? Okay, so this has a common difference of 2. And if we take these numbers and we add them up, and we do that 21 times, we're going to get 525. But why do that 21 times when we have our summation notation that turns into our sum formula that lets us find the answer very easily? Got it? Sorta? That's okay. We're just learning. We're learning. We're practicing, you know. We're starting to get it down a little bit. Okay, so again, just one more time, I just want to make sure that we're clear that this is the question, this is the how-to, and then this is just the simplifying of the how-to, just doing the math part, okay? And you've got to be able to write this question in summation notation, just like if I said, write me a recursive formula for this sequence, and you use the format to do that. You got to be able to do that. Or if I give you a question, or if I give you this in this summation notation, you got to know what to do with it, like we just did on that last question. Okay? Questions. Summation notation. How to find the sum of an arithmetic sequence. Oh, one more thing I wanted to talk about. Let's just talk about one more thing real quick, okay? What if, I'm just going to do this. I'm going to do this in a different color. What if I gave you this? Okay, well, yeah, let's set it up. What do you, like, let's just jot that one down below there. Okay, so what would this one, so I'll use a little arrow. What would this one turn into in some notation? You do it. Give it a shot. See what you can do. Get that. Whoa, yeah, what's going on there? Wait, where does the sequence start? At what term? The third term number. Where does it end? So how many term numbers are in this problem? Oh, not 8, 6. 3, 4, 5, 6, 7, 8. There's only 6 terms in this sequence. Oh, this is a partial sum. We can do this at any part of the sequence. We need to know how many term numbers there are, and then we plug them in, and then it's the starting term number, which in this case is 6, and the ending term number, which is 16. Okay, so this is 3 times what? which is,
Yes, sir. Please get ready for the afternoon announcement.
let's look.
Standard. We invite you to visit the Holy Cross Chapel every Thursday.
What's 6 plus 8?
From 8 a.m. to 3 p.m.
14.
Come to find some peace.
Keep going.
And quiet time.
24.
Where Jesus is there for you.
36.
Attention all students.
48.
A reminder that
50.
Friday is Spirit Dress Day.
66.
Wear dress code approved jeans and an SGM spirit shirt.
That's kind of handy, huh? If we got to find sums of notations of arithmetic sequences, that does a lot for us. All right, good job today, guys. We did good. Let me get you your homework.